Okay, guys, so this is screencast for what is today? The 19th of November. And we are looking at lesson 1. So all of these things come out of lesson 1 somewhere. So what is the straight line distance between a starting and ending point? What is that called? Displacement. Oh, awesome. Okay. How far an object travels. This would be measured by like an odometer in your car. The thing that keeps track of miles. Do what?
Miles/kilometers.
Well, but what is it called? Like, it's not displacement, but it's just distance. Okay. Okay. So a long, long time ago, my husband and I went to the Coca-Cola 600, which is a NASCAR race. Cars travel around a 1.5 mile track. If it is a 600-mile race on an oval track, first of all, how many laps would you have to do to go 600 miles?
400 laps.
It is 400 laps. How did you get that?
I multiplied 1.5 times 400.
No, you didn't.
That's what I did.
No, you didn't, because 1.5 times 400 is 600.
Yeah.
What'd you do?
You had to divide.
Divide. 600 divided by 1.5 is 400.
Oh.
Yeah. All right. What's the distance that the cars travel? It's the Coca-Cola 600. It's a 600-mile race. So how far do the cars travel? Yeah, 600 miles. Okay, 600 miles. Okay, and here's the big thing. This is what's really going to show you the difference between distance and displacement. What is the car's displacement at the end of the race? If you've ever looked at one of these races, they start at the starting line and they end up at the finish line, which is also the starting line. So they ended up where they started. So what is their displacement? 0. Yep. Okay. Oops, that's all crooked. Okay, so they're basically just going around in circles or on ovals, but they're not going anywhere, right? Mm-hmm. Okay, so their displacement is actually 0. Even though their odometer is going to say that they have traveled 600 miles, they haven't really gone anywhere because they're just going around and around and around a track. Okay, so speed is how quickly blank changes with blank. Distance changes with time. Very good. So what's our formula for speed, average speed?
It's total distance.
Good. Total distance divided by total time. Okay. Do that just so that the answers are a little bit easier to find. All right. All right, this question comes straight out of your homework, and you might even have to do it for homework. I don't even remember. Yeah, we did it. Okay, so look at page 176. It says, what's the average speed for an 880-kilometer trip that takes 9 hours? Well, okay, and that is not the word save. What is that? S which stands for speed, and then AVE, which stands for average. So this is average speed equals the, great, total distance divided by total time, 880 kilometers divided by 9 hours, okay?
I got 90 kilometers per hour.
Okay. And when you do it, it actually comes out to 97.8 kilometers per hour. Man, Miss Goff, how did you do that so fast? I looked at my lesson on page 176 where it's already done for me. There you go. Okay, are we good? This is so exciting. I just love Bellwork. It's great. Okay, the speed of an object at a specific moment in time is called. Top of one page. There you go, top of page 177. Okay, and if you were in your car, what would be measuring instantaneous speed? Like your speed right at that moment?
Speedometer.
A speedometer. There. All right, is everybody good? Okay. Now, there's going to be a lot of looking at graphs during this unit, so we might as well get used to it. This one is a very, very simple distance versus time graph, and I have 3 lines. I have object C, B, and A. Which line depicts the fastest object? Line A, line B, or line C? Which one's going fastest? C. How do you know?
Because it higher.
Okay, it's the steepest line. And basically that means that it is covering the most distance, the greatest amount of distance in whatever amount of time. Does it make sense? It's greatest distance in whatever time interval, so it's going the fastest. Okay, so my explanation, y'all said line C, and yes, I can tell because number one, the line is steeper than the other 2 lines, and also line C, if I look at like your distance and your time measurements, line C obviously is covering the most distance in the amount of time that's graphed. Is everybody good? Okay, flip over.